All right, so this is remove duplicates from sorted list. So given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. So example 1, 1, 1, 2, you'll delete the middle node, and then you have 1, 2. And then 1, 1, 2, 3, 3, you'll delete this one and this one so that you'll only have 1, 2, 3. Um, and each linked list will have a value and a next that points to the next node. The number of the nodes in the list is in the range of 0 to 300, and the value can be negative 100 to 100, and the list is guaranteed to be sorted in ascending order. All right. So I think the first thing that you would want to do is probably establish, store a pointer or two, um, store a pointer, and then check to see if it's, um, iterate over the nodes, check for duplicates. If duplicated, set the pointer of the non-duplicate node to another non-duplicate node. Refresh, and then refresh pointer position until you reach the end. Okay, so I think we'll establish one pointer, and we have the head node already. So we'll say current equals head, and then we'll want to do it until we reach the end. So the end condition would probably be while current is not none. And let me just check as I write this. Is there... Okay, so there potentially could be 0 nodes. So while the current is not none, because if it is, then you don't have anything. You return... And do we actually... Yeah, while the current is not none, and you also want to see if the current next is not none, like it's not the end, is not none. You're going to do some conditional logic to say, okay, if current val equals current dot next dot val, then you're going to basically set the... If it equals the next val, if the value of the current node is the same as the next node, then you'll want to skip over, I think. So maybe if you say current equals current dot val, current equals, no, you wouldn't change it. Current dot next equals current dot next equals current dot next dot next. But you don't know. I don't know if there is a value. So if current is a current, if current val equals current dot next dot val, else current equals current dot next. But in this case, you would want to, well, I guess you could just current, because it could be none. I think it can be none as long as you don't do anything. So current.next equals current.next.next. And that way you would eliminate the duplicate node. But you just wouldn't be able to do anything with the next operation in the while loop. And that's a fine because there's the while loop's condition is not none or the current.next. So you'd skip over. Otherwise, you just move the pointer up. Current equals current.next. So this one changes the actual, this one actually deletes the node or removes the node. This one, this line actually just moves your pointer up. So if the current val equals current.next not next val, then current.next equals current.next next. Okay. Now, and then you would return the head at the end. All right, let's see if this works. So in a node of, let's say this is, the first node is going to be 1, value of 1, next to next val is 1. Okay. Now, if the current is the head, which it is, it starts at the first one. Well, the current is not none. It is not none. And the current.next is not none. Then if the current val, which is 1, if it equals current.next.val, which it does, then it will current.next equals current.next next, which means 1, first node now points to current.next next, which is 2, third node. And then we continue with the while loop, and now we're at current is not next. So while current is not none, which it isn't, it's still the first node, and current.next is not none, which it isn't, it's the third node. If the current val equals current.next.val, which is it doesn't, then current equals current.next. So we're now pointing to the third node, which is 2. And then if we continue on, this one current is not none, but current.next is none. We exit and return the head with the list sanitized essentially, or removed the duplicates, and we have a solve. So the time complexity, the space complexity of this, we're only maintaining a pointer to the specific node, so it's going to be a constant space, and we are potentially going over every single node in the chain. So that means this has a linear time complexity, O of n.